Hi, I'm Wanrong from Georgia Tech, and our fourth paper is about attribute privacy, framework and mechanisms. And this is a joint work with Olga Ohrimenko, and she's at University of Melbourne, and my advisor, Rachel Cummings, and she's at Columbia University. Attribute privacy protects the global properties of sensitive attributes in a dataset from leaking during analysis. And for those of you who are familiar with differential privacy, we're used to think about privacy at the individual level, corresponding to rows of a database. And then we ask questions of the form. What can an adversary learn about Alice data based on an analysis of this dataset? And in this work, we instead consider privacy of attributes or columns of a database. And then we take the view of a database owner who wishes to publish aggregate statistics about her database and must also protect privacy of the aggregate information in certain sensitive columns. And in this example, the owner may wish to publish the average SAT score of its students. And let's assume that's non-sensitive information. And however, we know that SAT score are correlated with other sensitive attributes such as race, gender, and socioeconomic status. So even though SAT score is not sensitive, privacy protection is still needed to prevent leakage of these other attributes. And there are a few other use cases for attribute privacy. And for example, hospitals want to share the number of COVID cases with federal health agencies, but want to protect mortality rate that may affect future funding opportunities. And companies want to share client data for standardization, but want to protect proprietary information. And researchers providing data for reproducibility in peer review process, but don't want other researchers to perform new analysis on the data. And in general, attribute privacy concerned about sharing aggregate statistics about a dataset, but want to protect other aggregate properties which may be correlated with the shared information. And in the paper, we introduced two notions of attribute privacy. And the first one is dataset attribute privacy, which protects the attributes of a particular dataset. And for example, a company then trains a facial recognition model on its users, may wish to protect the demographic information of its users, such as race or gender, while still publishing the model. And we have seen some examples in recent literature where precisely this information was leaked. And our second privacy notion is distributional attribute privacy, and which protects the parameters of the underlying distribution from which the dataset was sampled. And for example, a pharmaceutical company running medical trials for a new drug is interested in the distribution of outcomes on the general population, not just the individuals selected for this trial. And in the paper, we propose definitions for capturing dataset and distributional attribute privacy by instantiating a general privacy framework called the pufferfish framework. And this framework was originally introduced to handle correlations across individual entries in the dataset. And we show that pufferfish framework can also be instantiated to accommodate correlations across columns, which is needed for attribute privacy. And we also gave several mechanisms to achieve attribute privacy. And we propose a attribute private Gaussian mechanism to satisfy epsilon delta dataset attribute privacy. We also propose an attribute private Markov code mechanism to achieve epsilon zero distributional attribute privacy. And there's a general mechanism for the pufferfish framework, so it can also be applied here, and it's attribute private Wasserstein mechanisms. For more details, please check our paper online, and thank you.